Surviving in the Arctic is not just about endurance, it is about understanding the science behind extreme cold and applying techniques that have been tested by explorers, scientists, and indigenous peoples over generations. The Arctic environment can drop below 40 DEC, winds can strip away body heat in minutes, and snow can both protect and endanger you. So how do people survive or even thrive in such unforgiving conditions? To begin with, shelter is the most critical priority. Have you ever wondered how a structure made of snow, something cold and seemingly fragile, can keep a person warm? Snow is actually an excellent insulator. It traps air within its crystalline structure, and air, being a poor conductor of heat, prevents warmth from escaping. One common Arctic survival structure is the quinsy, a snow mound that is hollowed out after being allowed to settle and firm up. Another is the igloo, which uses compacted snow blocks carefully arranged in a spiral dome. Inside these shelters, temperatures can stay around 0 DEGC, even if it's 40 DEGC outside, thanks to body heat and trapped warm air. Preventing hypothermia, a condition where body temperature falls below 35 DEC, is crucial. Hypothermia doesn't strike instantly, but it progresses quickly through stages. Early signs include shivering and numbness. Left unaddressed, it can lead to confusion, unconsciousness, and eventually death. How do Arctic explorers prevent this? One major method is layering clothing using the science of thermoregulation. The base layer wicks away moisture, sweat cools you down fast. The middle layer insulates, usually fleece or wool, and the outer layer blocks wind and water. Materials like Gore-Tex, synthetic insulators, and even aerogels have been developed to enhance heat retention without sacrificing mobility. But clothing is only half the battle. Maintaining dryness is just as important as warmth. Why? Because water conducts heat 25 times faster than air. If your clothes get wet, whether from sweat or snow, you lose body heat far more quickly. That's why Arctic survival techniques emphasize not just staying warm, but staying dry. Fire becomes essential not only for warmth, but for drying gear. Melting snow for water must also be done carefully. Drinking unmelted snow lowers body temperature and wastes energy. Navigation in snow-covered landscapes can be deceptive. The sun's low angle and the white landscape often create whiteout conditions where the horizon disappears. To cope, some Arctic travelers use snow goggles with narrow slits to reduce glare and improve contrast, a technique inspired by Inuit designs. In modern times, GPS and satellite beacons are critical tools, though they are not substitutes for knowing how to read terrain, track weather changes, and recognize signs of frostbite. Food is also a major concern. Cold weather increases caloric demand significantly. As much as 5,000 to 6,000 calories a day may be needed in extreme cold. High-fat and high-protein diets are favored because they release more energy and help generate internal heat. Traditional Arctic diets, rich in seal blubber, fish, and animal fat, reflect this biological need. Some may wonder, could we ever survive in the Arctic without modern technology? The answer lies in the ancient knowledge of indigenous Arctic communities. Techniques like using animal skins, building windbreaks, and tracking game migrations have allowed people to live in these regions for thousands of years. So, surviving in the Arctic is not just about facing the cold. It is about using physics, biology, engineering, and traditional knowledge to outwit an environment that constantly tests your limits. What would you do if dropped into an Arctic wilderness with only a knife and your clothes? The difference between life and death could come down to whether you understand the science of cold or ignore it. Heat loss in cold environments occurs via conduction, convection, radiation, evaporation, and respiration. Snow, despite being cold, contains trapped air pockets which drastically reduce heat transfer by conduction and convection. The goal of insulation is to retain body-generated heat, creating a microclimate that remains survivable even in extreme subtemperature temperatures. Materials with low thermal conductivity and high air content are essential in shelter and clothing design. A snow cave can maintain an internal temperature around 0 DSC even when outside temperatures fall below 30 DSC. Insulation in snow shelters works like a thermos, keeping the warmth in and the cold out. Snow shelters trap body heat within an enclosed volume while the walls block wind and reduce convective heat loss. The compacted snow creates a semi-solid insulating barrier, and the dome or cave structure minimizes surface area and supports weight efficiently. Entrances are often dug lower than the living area to trap cold air near the floor and allow warm air to stay higher. Over time, internal warmth may melt and refreeze inner walls, adding structural strength through recrystallized layers. Indigenous Arctic communities use igloos, leveraging snow's unique insulating properties for overnight shelter. A snow shelter is like a sleeping bag made of frozen air bubbles. It keeps the cold out by trapping warmth inside. Hypothermia begins when core body temperature drops below 35 DEC, impairing critical functions like muscle control, cognition, and heart rate. Heat is lost fastest from exposed areas, such as the head, hands, and feet. Due to high blood flow and surface exposure, the body shifts blood flow inward to protect organs, which can result in frostbite in extremities. Continuous exposure without insulation or metabolic heat generation from food or exercise can lead to unconsciousness and death. A person immersed in icy water can develop hypothermia in under 10 minutes, if not rescued. The body is like a furnace. Without fuel or insulation, its internal fire dims quickly in the cold. Modern cold weather clothing uses a 3-layer system: base, moisture wicking, mid-insulating, and outer windproof/waterproof. The base layer removes sweat to prevent moisture accumulation, which accelerates heat loss through evaporation. The mid-layer traps warm air using materials like fleece or down, while the outer layer protects against wind chill and precipitation. Each layer must remain breathable to allow sweat to escape and prevent internal condensation. Arctic explorers often wear merino wool underlayers, synthetic fleece, and Gore-Tex shells for optimal heat retention. Layered clothing is like building a house. First, you insulate, then you weatherproof. Modern survival gear incorporates materials engineered at the micro or nanoscale to maximize insulation and minimize weight. Aerogels, phase change materials, and reflective metallic films reduce thermal conductivity and reflect body heat back inward. Many garments also include hydrophobic treatments to prevent snow and moisture penetration. These technologies are inspired by spacesuits where heat conservation and breathability are critical for human survival. NASA-developed aerogel linings are now used in gloves and boots for extreme cold missions. Advanced cold weather gear is like wearing a spacesuit designed to protect against Earth's harshest environments. In cold climates, people often underestimate water loss, as sweat and moisture evaporate invisibly and the sensation of thirst is diminished. Cold air is also drier, leading to increased respiratory fluid loss. Dehydration thickens the blood, decreases circulation, and makes the body more prone to frostbite and hypothermia. Staying hydrated is as important in Arctic survival as it is in hot deserts. Despite the absence of visible sweating, military Arctic manuals stress forced hydration even when thirst is absent. Your body in the cold is like a leaky bucket. You may not see the water leaving, but you still run dry. Cold environments demand significantly more calories, up to 6,000 daily, to maintain body temperature and physical activity. Fats are preferred for long-lasting energy, while carbohydrates provide quick bursts of heat-generating metabolism. Warm meals also psychologically boost morale and stimulate internal warmth through digestion, a process known as diet-induced thermogenesis. A balance of macronutrients is essential to keep muscles functioning and prevent cold fatigue. Arctic trekkers consume high-fat snacks like nuts and cheese during rest periods to maintain energy. In freezing temperatures, your body is like a wood stove. It burns faster and needs a steady supply of fuel. Snow-covered terrain can disorient due to whiteout conditions, magnetic interference from metal, and absence of landmarks. The human eye struggles with depth perception in uniform white environments, increasing the risk of walking in circles or over crevasses. Tools like compasses, GPS, and sun shadows help maintain direction, while flags or markers are used to trace safe routes. Storms and shifting ice layers can dramatically change the landscape within hours. Experienced Arctic guides often rely on both traditional star navigation and modern satellite tools. Navigating in a snowstorm is like walking blindfolded through a blank canvas. You need tools to draw your way out. While wood is scarce in the tundra, fire remains vital for cooking, melting snow, and psychological comfort. Arctic survival kits often include multi-fuel stoves, chemical heat packs, and compact fire-starting materials that function in sub-zero temperatures. Animal fat, alcohol gels, and magnesium blocks can all serve as reliable fuel sources. Fire also prevents ice accumulation on tools and clothing, preserving functionality. Seal blubber has historically been used as an efficient, slow-burning fuel by native Arctic populations. A fire in the Arctic is like a life beacon. It provides heat, light, and a sense of continuity in a frozen world.